Okay, this is the excuse me, final part excuse me, of 5.4. So topic 5.4, and this was electric current and electric resistance. I talked about this in class today, so I'm going to go rather quickly through this. The potential drop. And in the potential drop, if you recall, I had a conductor, a lead, and a resistor, and then it went on again to a conductor. So if this is some resistor R, and I think I gave it like a 20 ohm value in class, but if we were to put a voltmeter along here and measure the potential difference across it, then we would find that there's a difference of voltage across this R of some value depending upon the value of R, so basically what it's saying according to Ohm's law is that if you have a resistance, and there's the R right there, and you have a current, so there's in the wire there is a current, then you are going to have a potential drop, a change in voltage as you go across something. Now contrast this with you remember I said we consider that there's no resistance in a piece of wire. So let's just say that you measured this, you looked at this. Remember I showed you what a multimeter looks like, and it was set up to read voltage, a potential difference. Let's say you measured it to be 20 volts, a potential drop across R. So there was a change in voltage of 20 volts across R. Now if you took that same voltmeter and you put it right here to right there on the piece of wire, you would find that it would register nothing. There is no potential drop there. So that's what I was meant by the resistance in a piece of wire is considered to be negligible to the total circuit. So that's the idea of potential drop. Just a couple more notes on potential drop. Whenever you go through a resistor and you have a current I and you have some resistance R, there will be a change in voltage V as it goes through it. And basically when we get to circuits, we're going to find that change in voltage is going to always add up to be the voltage of the source. And so you would lose all of your potential as you go around a circuit. And then I talked to you briefly about electric power. And again, I'll show you real quick. Power equaled V times I. And if you recall, that was a joule, not equal, these are the units. Joule per coulomb times a coulomb per second. And there you have a joule per second, which is a watt. So the same units of power as in mechanics. But the other quick things, power is not that hard to understand, but if we take Ohm's law, V equals IR, Ohm's law, and we do the plug-in, so if we plug in for V in this equation, you recall we got I squared R, and also be aware that you could solve this for I'll just highlight I right there, and if we solve it for I, that didn't really work very well. Let me do a little bit lighter highlight just there. If we solve this for I, we get I equal V over R. Getting cluttered here, but if we now plug that into Ohm's law for I, we're going to plug in V over R for that. We get it also power is equal to V squared over R. So that was the rest of 5.4, and that is all we're going to put into that. So here's what I'm going to do is I'm going to continue on the same slide into, no I'm not, I'm going to go ahead and stop. I'll load this up. It's only 4 minutes long, and I'll load it up, and you'll have a little 4-minute long video plus the 10-minute long one from earlier. All right?